students. Welcome to Sankalp Learning. So we are going to start with a new session. Okay, so here what we are doing, we are discussing the important question and answers. Okay, from the board pattern. Okay, from the board pattern. So I have taken the questions from the previously asked question papers. Okay, so different like your different this uh, uh, your preparatory exams, okay, and midterm exams, and so 5 years different your exams, okay, 5 year board exams. So from these different exams, okay, I have taken the important questions. So today we are going to start with the chapter biomolecules. So the biomolecules chapter, okay, from chemistry, it is the total marks allotted for this particular chapter is 9 marks. Okay, so out of this 9 marks, so 1 mark, 2 mcqs you will be getting. Okay, and then 2 marks, 1 question you will be getting, and 5 mark, 1 question you will be getting. So as you know, in chemistry directly 5 mark question is not asked. So again, the 5 mark question is either divided into 3 plus 2 or 2 plus 2 plus 1. Okay, so based on this uh, exam pattern, okay, we are going to start with the uh, this, okay, solving the paper. Fine. So first we are going to start with the MCQs. So let us start with the multiple choice questions. So this is the first question. So the first question is non-reducing sugar among the following is. Okay, so options are non-reducing sugar among the following is A, sucrose, B, glucose, C, fructose, and D, galactose. So which is the non-reducing sugar among the following? Yes. What is a non-reducing sugar? So a non-reducing sugar, okay. So what you are doing, so it cannot be reduced, right? Non-reducing sugars are the sugars which cannot be reduced, right? So they don't have a OH group attached to the anomeric carbon. Okay. So here among the following, which is the reducing sugar? It is our sucrose. Okay, so sucrose is the non-reducing sugar. So option number A is the answer. Okay, so here in sucrose, the non it is called as a non-reducing sugar. Okay, and it is made up of 1 unit of D glucose and 1 unit of D fructose. Okay, and this sucrose, it is a disaccharide. Okay, it is a disaccharide because it consists of two. When it undergoes hydrolysis, it splits into two sugars. It gives two sugars, that is your D glucose and D fructose. Okay, so it is made up of two monosaccharide units. Okay, and uh, as we say, why it is non-reducing sugar? Because the reducing groups of glucose and fructose, okay, they are involved in the forming of glycosidic bond. Okay, there is no free OH bond. Okay, fine. So the answer is option number A. I hope you have got it. Yes. Let us go for the next question. So the next question is, one molecule of sucrose on hydrolysis gives 2 molecules of glucose, 1 molecule of glucose plus 1 molecule of galactose, 1 molecule of glucose plus 1 molecule of fructose, and 2 molecules of fructose. 1 molecule of sucrose on hydrolysis gives. Yes, so sucrose, okay, when it undergoes hydrolysis, so sucrose is a disaccharide, okay, when it undergoes hydrolysis, okay, it will give you what? 1 molecule of glucose and 1 molecule of fructose, okay, 1 molecule of fructose. So our answer is option number C. Okay, option number C. So as I have said you that sucrose is a disaccharide. Okay, it is a disaccharide. It is also called as a cane sugar. Okay, it is also called as cane sugar. What do you mean by disaccharide? It is made up of two sugar units. Okay, it is made up of two monosaccharide units, that is glucose and fructose. Okay, so when it undergoes hydrolysis, it will easily split into D-glucose and D-fructose. Okay, fine. So answer is option number C. I hope you have got it. Yes. Let us go for the next question. A disaccharide is formed when two monosaccharides are bonded together by a dash bond. A. Glycosidic linkage. B. Peptide. C. Ionic. And D. Phosphodiester. So how a disaccharide is formed? Disaccharide means what? Disaccharide means it is formed by two monosaccharide units. Okay. So how the disaccharide is formed? How our disaccharides are formed. So so just now we have seen the example for sucrose. So sucrose, it is a disaccharide. Okay, it is made up of D-glucose and D-fructose. Okay, so how these two monosaccharide units are joined? They are joined through a linkage. Okay, that is a glycosidic linkage. Okay, it is a glycosidic linkage or glycosidic bonds. Okay. So as we have discussed, sucrose, it is what? It is a disaccharide units. Okay. They are the carbohydrates which are made up of two monosaccharide units. Okay. That is D-glucose and D-fructose. And how this is, how these two units are joined, how these two monosaccharide units are joined by a glycosidic bond. Okay. So what is this glycosidic bond? Okay, it is an ether bond. Okay, it is like a ether bond. It is a ether bond. Okay, formed by condensation of two alcohols. So when two alcohols are condensed, okay, from the monosaccharide units, you get this ether bond. Okay, which is a glycosidic linkage. Okay, I hope you have got the answer. So our answer is option number A. Okay, answer is option number A. So let us go for the next question. Which of the following statements is not true about glucose? Which of the following statements is not true about glucose? It is an aldohexose. On heating with HI, it forms N-hexane. C, it is present in furanose form. D, it reacts with hydroxylamine to give oxime. So they have given you four options. So they have asked which of the following about glucose is not true. Yes, which is the this which is not right. So aldohexose, what do you mean by aldohexose? Aldohexose means it consists of a aldehyde. Okay, aldohexose means it consists of a aldehydic group. Okay, so when we see the structure of your glucose. Okay, when you see the structure of the glucose, so it will be what? So let us write first the structure of glucose. So it will be CHO. Okay, HOH, 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 OH and CH2OH. Okay, so this is a structure of glucose. So it is a aldohexane. So it consists of a aldehydic group. So okay, so this statement is correct. Okay, then when you heat your what your glucose. Okay, so when you heat your glucose with HI. Okay, so when you heat it with HI, when you heat it with HI, okay, what I am going to get? I'm going to get a N-hexane. N-hexane means what? N-hexane, hexane means the number of carbon atoms are 6. So count 1, 2, 3, 4, 5, and 6. So yes, this is also correct. So this represents that the skeleton of the glucose, it consists of 6 carbon atoms, right? So glucose when it undergoes it is heated with your HI, okay, you are going to get N-hexane. So this is also a correct statement. So they have asked which is not true. So this is correct. This is correct. Then let us go for the next one. C option. That is, they say that it is present in Furano structure. But when you try to convert this, okay, so when it undergoes a okay, so what will happen here? So it will undergo what? Uh, okay, so you are going to get a, so what type, how many membered ring it is? So CH2OH, H, HOH, 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 HOH. Okay, so HOH, HOH. Okay, so like this. So this is a not a furan. It is a pyrano structure. 1, 2, 3, 4, 5 membered ring. Okay, so it is a pyrano structure. So this is a wrong statement. Okay, and when it reacts with hydroxylamine, yes, it gives oxime. So these other three statements are correct. Only option number C is wrong. Okay, because it is not having a furanose. Furanose means 4 membered ring. Okay, for furanose means 4 membered ring, but here you can see it is a 5 membered ring. Okay, 1, 2, 3, 4, and 5. I hope you have got it. Yes. Okay, let us go for the next one. Deficiency of which vitamin D causes rickets, scurvy, convulsions, beriberi. So deficiency of which vitamin D it causes rickets, scurvy, uh, convulsions, and beriberi. Yes. So the answer is rickets. Okay, so deficiency of which vitamin D causes vitamin D, it causes rickets. Okay. So vitamin D, it causes rickets. So ricket means what? It is a bone disease. Okay. It is a bone disease which will affect the your small kids. Okay. And very small kids, infants and young childrens. Okay. So it is rickets is a bone disease. Okay. So what does vitamin D, if you take like more amount of vitamin D, so it will help the body, okay, to use the calcium, okay, from the diet. Okay, so we know that for the bones, what is required? Calcium is required. Okay, so if you take additional calcium from the supplements to your diet, okay, the disease, okay, your rickets, that is the bone disease, it will get cured, okay, and your bones will get stronger. Okay, so if the child is not getting enough vitamin D, okay, then the child may undergo the bone disease, that is the rickets. So what the bones will be not strong, it will be like soft tissue. Okay, so and other some different disease may cause. So because of that, so you have to take like in the supplement, at least you have to take the more amount of vitamin D. Okay, so that calcium is taken in proper diet and your bones get stronger. Okay, so option number A, deficiency of vitamin D causes rickets. Okay, yes. Let us go for the next question. Lactose gives on hydrolysis. Glucose and galactose, C fructose, and D glucose and fructose. So when lactose, okay, when lactose undergoes hydrolysis, what it gives? Yes, what it gives. So when lactose, okay, undergoes hydrolysis, when lactose undergo hydrolysis, it will give you beta D galactose, okay, beta D galactose and beta D glucose, okay, and these are in equal amount. So both are in equal amount. So your lactose is C12H22O11, okay. So when it undergoes hydrolysis, it will give you C6H12O6 plus C6H12O6. Okay. So this is the so here which is the enzyme in lactose? It is a lactase. Okay, lactase is the enzyme. Okay, so it will break down, this lactase enzyme will break down the lactose, okay, in the milk, and it will release glucose and galactose. So our answer is option number B. Okay, our answer is option number B. Yes. Let us go for the next one. Glucose on oxidation with nitric acid gives A. Saccharic acid, gluconic acid, glyceraldehyde, and hexane. So when glucose, okay, if glucose, okay, C6H12O6. So when it undergoes what? When it undergoes oxidation, okay, when it undergoes oxidation in the presence of nitric acid. So oxidation means what? Addition of oxygen. Okay, addition of oxygen. So in the presence of concentrated HNO3. Okay, nitric acid is HNO3. So when it undergoes this, okay, what it gives? I'll write the this only, okay. So CHOH 4 times, okay, and CH2OH, okay. So when it undergoes oxidation in the presence of concentrated HNO3, so what will happen? Both the your aldehyde and your primary alcohol, okay, it will be converted into what? It is converted into your COH, okay, that is acid. So you are going to get what? You are going to get a saccharic acid. Okay, I'm going to get saccharic acid because the this what your nitric acid is a strong oxidizing agent. Okay, it is a strong oxidizing agent. So what it will do? It will oxidize both your aldehydic OH as well as your alcoholic OH to what? To the carboxylic acid. Okay. So our answer is option number A. Our answer is option number A. I hope you have got it. Yes. Okay. Let us go for the next question. Question is, a carbohydrate that cannot be hydrolyzed into simpler units is called polysaccharide, trisaccharides, disaccharides, and monosaccharides. So a carbohydrate cannot be hydrolyzed into simpler units. Okay. Now, when a carbohydrate, now polysaccharide, poly means many. Okay, so when you have many monosaccharide units, so when your when your carbohydrate is made up of many monosaccharide units, okay, so when it undergoes hydrolysis, it will split into the each monosaccharide unit. Okay, trisaccharide means what? It is made up of three. So when it goes a hydrolysis, it will split into three monosaccharide unit. Okay. Disaccharide means what? It is made up of two. Okay, two monosaccharide units. So when it undergoes hydrolysis, it will split into two monosaccharide unit. Okay, but monosaccharide unit, what is monosaccharide? It is made up of one. Okay, so a carbohydrate, it cannot be hydrolyzed. Okay, so this carbohydrate, monosaccharide carbohydrate, it cannot be hydrolyzed into simpler units. Okay, so our answer is monosaccharide. So monosaccharides are what? They are the simplest form of carbohydrates. Okay, so they are made up of only one monosaccharide. Okay, they are made up of only one unit. So these cannot be hybridized further into the simpler unit. So our answer is option number D. Okay, answer is option number D. I hope you have got it. Yes. Okay, let us go for the next one. In fibrous proteins, polypeptide chains are held together by van der Waals forces, covalent bonds, electrostatic forces of attraction, disulfide bonds. Yes. How in fibrous proteins the polypeptide chains are held? So when you see the polypeptide chain, okay, they run parallel. Okay, they run parallel to each other. Okay, they run like if I or you can consider like this. Okay. So this polypeptide chain is what they are running parallel to each other, or you can consider like this also. Okay, so these are parallel to each other. Okay, and how they are held together? They are held together by the hydrogen and disulfide linkage. Okay, they are held together by hydrogen and disulfide linkage. Okay, hydrogen and disulfide linkage, and they form fiber-like structure. Okay, and what they form? They form like fiber-like structure. Okay, so our answer is option number D. Our answer is option number D. So because they are forming fiber-like structure, they are called as fibrous proteins. Okay, fine. Which of the following bases is not present in DNA? Adenine, thymine, cytosine, uracil. Yes. So when you see the bases, okay, in DNA and in RNA, okay. So in DNA, what are the bases present? The bases present are adenine, guanine, okay, then cytosine, then you have thymine. So these are the bases present in your DNA. And in your RNA, adenine, guanine, cytosine, and instead of thymine, you have uracil. Okay, so the basis which is not present in DNA is uracil. Okay, so uracil is absent in DNA, but it is found in your RNA. Okay, yes. Let us go for the next question. Nucleotides are joined together by Nucleotides are joined together by phosphodiester linkage, peptide bonds, glycosidic linkage, glycosidic bonds, or disulfide bonds. How the nucleotides are joined? Yes. So if I show you a nucleotide, okay, polynucleotide. So this is your phosphate group, okay. Then you have your sugar. Then for that your base will be attached. Okay, your base will be attached. Then again phosphate group. And thus this will continue. It's like this. So a polypeptide chain, okay, so you'll be having this particular. So one, what is there? One, you have a deoxyribose sugar, okay, deoxyribose sugar, you have a nitrogenous base and a phosphate group. And how they are, how these nucleotides are joined? They are joined together by what? They are joined together by a phosphodiester linkage, right? Option number A. Okay, so you can see between the 5' and 3' carbon, okay, of the pentose sugar. So here, okay, so here you can see that what is there? The nucleotides are joined. Okay, so the nucleotides are joined together by what? What type of linkage is present? Phosphodiester linkage. So option number A. Which of the following is a purine base? Yes, guanine, cytosine, thymine, and uracil. Which of the so you know that there are two types of bases, purine bases and pyrimidine bases, right? So which is a purine basis? So guanine, cytosine, thymine, and uracil. So purine bases means what? Purine bases are they are made up of 5 and 6 membered rings. Okay, and these 5 and 6 membered ring, they contain nitrogen. They contain nitrogen and they are fused together. Okay, so which are the purine bases? So they are adenine and your guanine. Okay, adenine and guanine. They are your what? They are your uh, uh, purine bases. Okay, adenine and guanine. Okay. And which are the pyrimidine bases? Pyrimidine bases are your cytosine. Then they consist of thymine and uracil. So other three are the pyrimidine bases. So which is our purine basis? It is our guanine. Option number A. Okay, option number A. Let us go for the next question. Deficiency of which vitamin causes disease scurvy? Vitamin D, vitamin A, vitamin E, vitamin C. Yes, deficiency of which vitamin? So when you have less amount of which or when you lack less like vitamin, which vitamin you are going to cause the disease scurvy? So when you have vitamin C, okay, less amount of vitamin C, so it will cause your scurvy. Okay, vitamin C is nothing but your ascorbic acid. Okay, ascorbic acid. So if you have a very less amount of ascorbic acid or the vitamin C in your diet, okay, for a very long time of period, then you are going to cause this particular disease, that is a scurvy. Okay, it is a scurvy. So whoever does not get a proper nutrition of vitamin C will cause this particular disease, scurvy. Okay. Okay. Next question. The water soluble vitamin is the water soluble vitamin is. Okay, so vitamins are water soluble and water insoluble, two types of. So the water soluble vitamin is okay. So vitamin C and vitamin B complex. Okay, vitamin B complex. So these are the water soluble vitamins. So vitamin C and your vitamin B complex, that is your B1, B2, B3, okay, B5, B6, B7. B9 and B12. Okay. So these are the your water soluble vitamin. So your which is the water soluble vitamin? Vitamin C. So vitamin A, D, and E, they are the water insoluble vitamin. Okay, they are whatever insoluble vitamin. Vitamin C is a water soluble. Okay. So option number D. Okay. Let us go for the next one. Alpha helix structure of protein is stabilized by peptide bonds, van der Waals forces, hydrogen bonds, dipole-dipole interactions. So how the alpha helix structure of protein is stabilized? Yes, how it is stabilized? So it is stabilized by the hydrogen bonds. Okay, it is stabilized by the hydrogen bonds. Okay, so what it does, it stabilizes your alpha helix structure. Okay, so alpha helix structure is nothing your secondary structure of your proteins. Okay, and it is spiral. It is having a spiral conformation. Okay, it is having a spiral conformation like this. Okay, so it is having a spiral conformation. Wait. Yes. Okay. So what it is doing? So it is stabilizing. Okay, your hydrogen bond, they are stabilizing this alpha helix structure. Okay, and it is like a spiral conformation, and it consists of so every backbone. Okay, NH group. What it does, it donates your hydrogen bond to the backbone of the carbonyl group. Okay, so our answer is it is hydrolyzed by hydrogen bonds. Okay, let us go for the next one. Each polypeptide in a protein has amino acids linked with each other in a specific sequence. This sequence of amino acid is said to be. Each polypeptide in a protein has amino acids linked with each other in a specific sequence. This sequence of amino acids is said to be. Yes. So we know that when you see the protein configuration, okay, when you see the polypeptide chain, okay, so each amino acid, it is linked together, okay, with each other in a specific sequence, okay, and this sequence, it is called as what? It is called as the primary structure of proteins, okay, it is called as the primary structure of proteins, okay. So in primary structure of protein, what is done? The polypeptide, okay, in each protein, the amino acids they are linked together, okay, with each other in a specific sequence. Specific sequence, okay. So primary structure of proteins. So it is like a linear. Primary structure is linear. So it consists of each amino acids, okay, that is which is linked in a sequence. It is like a sequence. Secondary is how? Secondary is like a spiral. And tertiary is like your, like this, okay. And quaternary is very, very, what? Rigid. Okay, so like this. So primary, it is linked in a each specific sequence. Okay, let us go for the next question. Okay, starch is a polymer of. Starch is a polymer of. So, alpha D glucose, beta D glucose, alpha D fructose, and beta D fructose. Okay. So, what is a starch? Starch is a polysaccharide. Okay. Starch is what? It is a polysaccharide. Okay. It is a polysaccharide. So, how polysaccharide means what? It is made up of many units. It is made up of many units. Okay. Now, of which unit it is made up of? It is made up of glucose unit. Okay. It is made up of glucose unit. So, many glucose unit join together to form the starch. Okay. So, here, what is the function of this starch? It is like what it does. It stores the energy. Okay. It stores the energy in the plants. Okay, it stores the energy in the plant. So it is a polymer of glucose. Okay. Alpha glucose, alpha D glucose. So starch is made up of what? It is made up of alpha D glucose. So option number A. Okay. Next question. Which of the following does not have glycosidic linkage? Sucrose, amylose, galactose, maltose. So which does not have a glycosidic linkage, students? Galactose. Okay. Galactose, it does not have a glycosidic linkage. Okay. So in sucrose, there is a glycosidic linkage, right, between the glucose and the fructose. Then in your amylose sugar, okay, it also consists of what? It is also consists of alpha glycosidic bond. Okay, it is a polysaccharide. Then maltose, okay, it is a disaccharide. Okay, and it also consists of it is made up of glucose unit and 1,4 glycosidic linkage is present. Glucose also galactose. In galactose, there is no this, okay. What? There is no glycosidic linkage. Okay, how the glycosidic linkage is formed? One sugar is joined with another sugar. Okay, galactose, in galactose, there is no glycosidic linkage. So our answer is C. Next question. The two cyclic forms of glucose differ only in the configuration of the hydroxyl group at C1 are called. Yes, when you see that there is a change in configuration at only carbon number 1. Okay, suppose I give you the structure like this. Okay, let me write the uh, alpha D glucose and beta D glucose. Okay, anomers, the pyrano structure. So this is your alpha D glucose. Let me write the beta D glucose. Okay, so this is a beta D glucose. So what you can see, there is a change at only the C1 carbon. So at the C1 carbon, you can see OH is above. Here it is below, right? So alpha D glucose and beta D glucose. So these are called as anomers. So when you have these two cyclic, so the two cyclic forms of glucose they differ only at C1. Rest all the other configuration is same. only the configuration of the C1, okay, is changed. So these are called as the anomers. So these are called as what? These are called as anomers. So anomers are what? So you can see in anomers that there is a change in configuration of the hydroxyl group, okay, at the C1. Then it is called as anomers, okay. Lysine is basic amino acid, acidic amino acid, uh, amino acid synthesized in body, and non-essential amino acid. What is a lysine? So lysine is what? Yes, lysine is a basic amino acid, right? So lysine is a basic amino acid. Okay. So option number E. So it consists of a basic group, right? So it consists of a basic group. So lysine structure is like this. Okay, NH2, NH2. So additional NH2 is there. So it is a what? It is a your basic amino acid. Okay. So answer is option number A. Nucleic acids are the polymers of nucleosides, nucleotide bases, and sugars. So nucleic acids, they are made up of, or they are the polymers of what? They are the polymers of nucleotides. Okay, what are these nucleotides? They are the fundamental units. Okay, they are made up of what? They are made up of the your nucleic acids like your DNA and RNA. Okay, so these nucleotides, they consist of three parts. One is your sugar, okay, one is your base, nitrogenous base, another is the phosphate group, right? So our answer is, so nucleic acids, they are what? They are the polymers of what? They are polymers of nucleotides. Okay, so option number B. So how these nucleotides are obtained? By repeated units of repeatedly it consists of monomeric units, right? Repeated okay, monomeric units, they make up this nucleotides. Okay, yes. So these were some of the MCQs based on the chapter biomolecules. Okay, so together there are so two questions will be asked from this particular chapter biomolecules, two MCQs questions. So these were some questions which we have discussed today. Okay. So in the next session, we'll be discussing the uh, we'll be discussing the 2 mark and 5 mark question. Okay, so this total number of marks allotted for this particular chapter biomolecules is 9 marks. So this is a very easy and you can score very easily in this chapter biomolecules. Okay, so uh, yes, so we'll be discussing the remaining part in the next session. Thank you.